All right, so since I can't be in class today, I am making this video for you guys to watch and listen to. The beauty of having this is the fact that you can stop and rewind the video whenever you need to, or you can just stop and pause it, do whatever you need to so that you can make sure that you get all the notes. There's going to be a couple tasks that you need to be able to complete throughout the video, so make sure that you're paying attention to all of those. So we're going to continue with section 7.2, which is going to start to talk about specific quadrilaterals. The rest of the chapter is all about quadrilaterals. We're going to start with a very general form of looking at parallelograms and understanding what those are and the properties that go along with it. And then we'll start getting more specific later on in the chapter. So I guess the first thing is to talk about what the definition of a parallelogram is that you guys should be aware of as of right now. So a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel to each other. And so being parallel, the top and the bottom are parallel, as well as the two sides are parallel. The thing is that there's a lot else that is going on in a parallelogram, the fact that you have two parallel lines. And so now what we're going to be looking at is we're going to be taking a look at a couple different properties and things that you can go ahead and assume when you are working with parallelograms. A couple of general things is, yes, we can assume that there are four sides. Yes, there are four angles. Another thing too is we know that since it is a quadrilateral, all of the interior angles will add up to 360 degrees. All of the exterior angles will also add up to 316. Now we're going to try and get into a couple things that are more specific. So there are 5 properties that we're going to talk about. There's also going to be one additional property that we'll add here at the end. But properties of parallelogram, first one, we just talked about it, and that is that opposite sides are parallel. Okay, so we just talked about that one. I mean, that's really what the definition of parallelogram is. The second property that we're going to be looking at is also dealing with the opposite sides. And this time, opposite sides are also congruent. And so if you have a parallelogram, you can go ahead and assume the opposite sides are parallel to each other. If I take a look at this parallelogram right here, I know that these sides here are parallel. I know these sides here are parallel. I also know that the opposite sides have to be congruent to each other. Not necessarily are all 4 sides going to be equal to each other, but opposite sides will be congruent to each other. The third property is starting to work with the angles, and we're going to talk about how opposite angles are congruent. And when I talk about opposite angles here, I'm referring to this bottom left angle and the top right angle there. Those angles are opposite angles, so they would have to be congruent to each other. The top left and the bottom right angle here, those angles would have to be congruent as well. The 4 angles will not be congruent to each other unless we are working with a square or a rectangle. But we can assume that opposite angles are congruent to each other. We also can assume that 4 angles will add up to 360 degrees. So keeping that in mind, but when you look at a parallelogram here, notice that 2 of these angles appear to be acute angles and 2 of them appear to be obtuse angles. Then, leading with this whole idea of angles, I'm actually going to go back here. The next property goes back to chapter 3. Actually, was it chapter 3? Yeah, chapter 3, when we were working with parallel lines, and we talked about transversals. What ends up happening here is that I end up with 2 angles that are not congruent to each other, but they are consecutive interior angles, which means that they are going to add up to 180 degrees. And that would go for the other side here as well. Here I have a transversal. So the fact that I know that the opposite angles are congruent to each other, the two consecutive interior angles are going to add up to 180 degrees. We can also assume the same thing with the two top angles as well as the two bottom angles. Those are also going to add up to 180 degrees, which in the long run there ends up saying that we get the 360 degrees that we're looking for. So our fourth property is that consecutive angles are supplementary. So they're going to add up to 180 degrees. Now I'm going to erase what I have on here just so I can get to the last one without all this stuff on there. The last property that we're going to talk about has to do with the diagonals. And a diagonal of a parallelogram is a segment that's drawn from one vertex to the opposite vertex. And we can draw two diagonals when we look at a parallelogram. And what ends up happening here is that these diagonals obviously cross at some point, and they end up bisecting each other. And so what that means here is with our diagonal that it's going to divide it up into two equal parts on both directions. Diagonals are not necessarily congruent to each other. It is possible that they could be, but it's not required that they are. So realize that all four of these segments will not be congruent to each other all the time. So we might have different measurements that are there. So the last one here is diagonals bisect each other. All right, so those are the 5 properties that we're going to look at. I'm going to take a look at just 3 examples real quick that you'll be looking at coming up here on your assignment using these properties. So the first one is right here. Let's say that I'm asking you to find the value of x so that this quadrilateral is a parallelogram. If that's the case, we would want the lengths of the opposite sides here to be equal to each other. So if I have 9x minus 25 is equal to 5x plus 7. So I'm going to go ahead and subtract 5x from both sides. So 4x minus 25 is equal to 7. I'm going to add 25 to both sides. And 4x is equal to 32. So then if I go ahead and take 32, divide both sides here by 4, we get that x is equal to 8. And so if x was equal to 8, then I would have a parallelogram because opposite sides would be congruent to each other. Another example here working with a diagonal. This is saying here that this entire diagonal is 74, and if I know that diagonals bisect each other, so that means this segment and this segment are going to be the same. If the whole segment is 74, then half of it would have to be 37, so the other half would have to be 37 as well. So I could go ahead here and say that 4x plus 1 is equal to 37, and subtract 1 from both sides. 4x is equal to 36. Divide by 4. And I'm left with x is equal to 9. Another option that you also could do here is you could double your 4x plus 1 and set that equal to 74. And if we do that, we'll get the same thing. Probably one of the harder problems for people to do is working with the angles in a parallelogram. And so a couple things to think about here is, first of all, with angles, opposite angles are congruent to each other. And then also consecutive angles are going to be supplementary to each other. So with that, I'm going to start with the fact that we have two parallel lines. I'm going to start at the top here, and I'm going to start with the bottom. And I'm going to use the diagonal here as our transversal. And with a transversal line, what I know is that we can have alternate interior angles then. So if this bottom angle here is 18, this top angle here would have to be 18 degrees. Now, when I look at this whole angle right here, 42 plus 18, so that ends up getting us 60 degrees. Opposite angles are congruent to each other, so this angle right here would also have to be 42 degrees. If I think about a different diagonal, and if I were to get rid of something, we could kind of also work with those alternate interior angles, but more so those 18s are the alternate interior angles, and the 42 fits in there because you are working with, actually I suppose I'll make it this way. If I do these two parallel lines right here, and then I work with this transversal, now the two 42s, those are alternate interior angles too. All right, so with that being said, now I know that also alternate or consecutive interior angles are supplementary to each other. So this angle right here is 60. And so if I take the angle here 60 and this entire angle here, those have to add up to 180. So 180 subtract 60 gives me 120. Well, if 115 degrees is right here, that means that this angle would have to be the remaining 5 degrees. This whole angle here is 120 degrees. This whole angle here is 60 degrees. This whole angle here is 60 degrees. Since opposite angles are congruent to each other, I know that this whole angle also has to be 120 degrees. If I use that same concept that we just talked about, and I take a look at these parallel lines, sorry about that, and I take a look at the transversal, I'm going to put the transversal here in yellow. What I have here is I have some alternate interior angles. I have the 115 degrees up here, which is going to be an alternate interior angle down here on the bottom. Also working with alternate interior angles, I can assume that this angle here is 5 degrees. So with alternate interior angles, as well as saying that consecutive angles are supplementary and opposite angles are congruent, we could fill in all the missing angles. All right, so next what we're going to do is we're going to kind of get into a area where we're going to be proving whether a quadrilateral is a parallelogram or not. Not necessarily in the form of a two-column proof, but just kind of using some algebra to show it. And so here we're going to be looking at, is quadrilateral FROG a parallelogram? So what I would like you to do at this time is, actually, hold on, I'm going to do this first, sorry. So when we talk about properties of a parallelogram, I talked about 5 properties that there are. And opposite sides being parallel, opposite sides are congruent to each other, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So what we're going to be doing here is we're going to try and figure out what kind of things we can use to try and verify these properties. Because if we can verify one of these properties, then we can prove that it's a parallelogram. Now, with angles, those are going to be really hard to work with unless you're sitting there working with a protractor and you have it graphed out absolutely perfect. So, and we don't have anything that can just measure it just by giving you coordinates. So we're going to leave those two. Diagonals bisect each other. I'm going to come back to that one at a later date. And so we're going to be using the opposite sides being parallel, opposite sides being congruent to each other. If we can prove that information, then we can go ahead and assume that we have a parallelogram. Now there's one other property that I'm going to bring up here, and that is that a parallelogram, if you can prove that a quadrilateral has one pair of opposite sides that are both, and that's the key part here, that they are both parallel and congruent, you would be able to show that it's a parallelogram. So that's going to be the other one that I'm going to show you. Okay. So now what I'd like you to do is, if you were to go and the substitute teacher has a piece of paper for you to grab, and then we're going to be walking through it. So go ahead and pause the video and then come right back. All right, now that you're back, you have a piece of paper that you got from the sub. It looks something like what you see here. And what we're going to talk about is we're going to talk about 3 different methods of proving that parallelograms are, or proving that a quadrilateral is a parallelogram. So method number 1 is to prove that both pairs of opposite sides are congruent to each other. And so what that means is that we need to be able to show that if AB is congruent to DC, and if we can show that AD is congruent to BC, then quadrilateral ABCD is a parallelogram. If we're going to show that segments are congruent to each other, then we're going to go ahead and use our distance formula. So yes, we're going to have to use our distance formula. We're going to use it 4 times in order to show this. Your other option is to prove that both pairs of opposite sides are parallel to each other. So here we need to take AB and show that it's parallel to DC. We also would need to show that AD is parallel to BC. And if we can show that they're parallel to each other, then we have a parallelogram. Now to do that, we're going to be using our slope formula. And then lastly, if we can prove that one pair of opposite sides are both congruent and parallel to each other, then we have enough information. So if I can prove that AB is congruent to DC, and we can prove that AB is parallel to DC, then it's a parallelogram. So what's going to happen here is we're going to have the best of both worlds here. We're going to have to use the distance formula 2 times, as well as the slope formulas. So what I'm going to do is, on your little piece of paper that you have, there are some examples, and we're not going to go through all of them. I'm just going to kind of pick one of each area and have you be looking at those. And to just go ahead and show you how are you going to prove that you have a parallelogram or not. So let's take a look at number 1. You have 4 points. Now definitely you could graph out these 4 points and try and picture it there. But say you were working with decimals or any irrational numbers, something like that, or very large numbers, it's going to be harder to graph this out. So using numbers here that are easy to work with to help you visualize them, we're going to be using our distance or slope formulas to help us prove if it's a parallelogram. So the first one here says determine whether the figure is a parallelogram using the distance formula. So what's going to happen here is that when you see these numbers here, they're listed in order. So AB would be one side, BC would be a second side, CD would be the third side, and then AD would be your fourth side. Okay, so using the distance formula, you need to find the distance of AB. We need to find the distance of BC. We need to find the distance of CD, and we need to find the distance of DA. Okay, so distance formula, you can see it right on the wall. What I would like you to do is you're going to, at this time, pause the video, and you're going to show the distance formulas. You're going to be getting points for this assignment that's worked out. So what I want to be able to see is I want to see your work to go along with it. So show me what numbers you are plugging in just to show you. So AB here, if I take 2 minus 4, take that quantity squared, plus 1 minus a negative 7, that answer squared. And so now if I work this out, I've got 2 minus 4, so that's negative 2 squared, so that's 4. 1 minus a negative 7, so that's 8. 8 squared is 64. And so then I get the square root of 68, and I'm going to go ahead and leave it right there. So what you're going to do is pause this video. You're going to fill in the information here, and then you're going to start it back up, and we'll see what our answer was. All right, I'm not going to fill in this information because you should have that on your own in order to get the full credit. But what you should have gotten here is that AB is the square root of 68. BC is the square root of 164. CD is the square root of 68. And DA is the square root of 164. So when I look at this, hopefully you can now see that the opposite sides here are congruent to each other. So we can go ahead, and I didn't leave a whole lot of room here, but ABCD is a parallelogram. And because opposite sides are congruent. Okay, so again, I should see when you get this turned in, you should have numbers filled in for these spaces here. Okay, that's what I'm going to be looking for you to do in order to get the full credit. All right, let's take a look at another example. I'm going to go over to the back page. We're going to look at number 3. Again, we're not going to do all of them. Here it says determine whether the figure is a parallelogram using the slope formula. So using the slope formula, we're trying to show that opposite sides would be parallel to each other. So again, with the sides, one side would be WX, the next would be XY, followed by YZ, and then you have the fourth side of WZ. So we're going to go ahead and find the slope. So I'm going to find the slope of WX. We're going to find the slope of XY. We're going to find the slope of YZ. And we're going to find the slope of WZ. So using your slope formula, which I'll show you in the first one here of WX, take the change in Y, so negative 6 minus a negative 4, divided by 1 minus a negative 7. So negative 6 minus a negative 4, it's adding 4, so I get negative 2 over, and 1 minus a negative 7, that's going to give us 8. It will be in your best interest to simplify things, and so you should get negative 1/4. What I'd like you to now do is to pause the video and find the slope of the remaining 3 sides. Once again, I'm going to be looking for your work to go along with this in order to be getting the full credit. So go ahead, pause the video, start it up when you're ready. All right, so now that you've got this, here we should have gotten that WX is negative 1/4. XY, you should have gotten that to be negative 1/4. And let's see, I'm sorry, I think I did the wrong one there, my fault. right, xy. xy is negative 7/4. yz is negative 1/4. And lastly, wz is negative 1. Now, if I look at these two sides here, negative 1/4 and negative 1/4, those two are parallel to each other because they're the same slope. But then we have negative 7/4 and a negative 1 right here. Those are not parallel to each other. They're not the same slope. So here we can conclude that, let's see, I'm using wxyz. So wxyz is not a parallelogram because opposite sides are not parallel. So there's your second choice, different method to do. Last but not least, we're going to take a look at the third option, which is using the slope and the distance formula to figure out if it's a parallelogram. And here you're looking at one pair of opposite sides. So once again, JK is one side, KL is another, LM is another, and then JM. If, however, we're going to be looking at opposite sides, if I take the opposite side here of JK, opposite of JK will be LM. So what we need to first of all do here is figure out what is the length of JK using your distance formula. What is the length of LM using your distance formula. Then we need to find the slope of JK, and we have to find the slope of LM. So what I want you to do is go ahead and once more pause the video and fill in our slopes and our distance formulas here to figure out what they are, and then once you have that, go ahead and start it back up. All right, JK, you should have gotten the square root of 25, which is 5. LM is also square root of 25, which is 5. The slope of JK is 3/4, and the slope of LM is also 3/4. So what I have here is I have two sides that are congruent to each other, and I have two sides that are parallel to each other. They're not just any two sides, it is the opposite sides. So we can go ahead and say here that JKLM is a parallelogram because one pair of opposite sides is both parallel and congruent. All right, so you've made it through the video. What I would like you to do is make sure that your name is on this piece of paper. You're going to hand it in, and when you hand it in, you need to pick up your assignment from the substitute, and that will be due then for class tomorrow. So that's it.